Welcome to the Houston Urban Debate League Space Policy Day. We're going to have a lot of fun today. It's going to be very interesting, and I know that it's a special occasion for you. Yesterday I told you that I thought you'd hit the jackpot on this year's high school debate topic, and kind of wished I could go back and be a debater again for a while. If yesterday was the jackpot, I guess today's the daily double, in the sense that you find yourself here at the Baker Institute, our hosts for today. And this is a place where maybe in a few years some of you will be doing your graduate research fellowships, or maybe in a lot of years after a stellar career you'll retire here and teach others about those great policy issues that you used to debate about and then that captured your life's interests and move forward. As I said to you last night, you're receiving quite a gift today. As you look down the speakers list, you'll see, presidential advisors, astronauts, business people, entrepreneurs, all very successful in the field of space and space policy. And they all decided, once I was able to chat with them a little bit and tell them, well, I've got 200 kids that are going to be debating about space for a year. Won't you take your day, the most precious thing that you have, your time, and come and share some information with them? And it was one of the easiest convincing jobs I ever did. And so I just wanted to thank all of our speakers, to thank Baker Institute, and to thank you guys. It's going to be a fun day, and we look forward to a lot of interaction. Don't be shy. We have microphones and questions, and this really is for you. Today is really your opportunity to remember. Yesterday I talked about you got to bring the real world into your debate. Well, that's where you are today. This is part of the real world, and you'll meet and talk with people that are actually involved in the kinds of things that you're discussing, researching, and analyzing. So I know it's going to be fun, and without any further delay, I will reintroduce Elizabeth Campbell, who is the president of the board of Houston Urban Debate League. So she's the big kahuna here today. And she's also a partner at Andrews & Kurth and the chief diversity officer. Besides that, she's a great person and a good friend. Thank you very much, Elizabeth.
Good morning again, everyone. I am delighted to welcome you here, and I want to give thanks again to Mr. Abbey and to the James A. Baker III Institute for Public Policy here at Rice University. It is a fitting environment to talk about this topic, and we could not be in a better place, and we could not be in a finer city to host this event. So it is my pleasure to welcome you here on behalf of the Houston Urban Debate League. Let me give you a quick overview of our day. We are filled with individuals who could frankly carry the day. You're getting keynote after keynote after keynote. So get ready, fasten your seatbelts. We'll be welcomed. Next I'll introduce our county judge, Judge Emmett. Then we'll hear our keynote speaker, one of our astronauts here today. We'll have a panel to talk about space policy, options, and implementation. We'll take a break, then we'll hear from another astronaut. Then we'll have a tribute to the founder and father of commercial space. We'll end with a discussion about what's next in space. Oh, what a timely topic, and oh, what a timely place to hold this event. Your questions will make this possible. We are webcasting this, and we will have a vehicle to have communication into this room through email so that we can make sure we're getting all questions and we're making sure that we're keeping this stimulating. So without further ado, let me begin by introducing our first speaker, the Honorable Edward M. Emmett, Judge Emmett as we know him here in Harris County. Judge Emmett became Harris County Judge on March 6, 2007. Prior to that, he served as a member of the House of Representatives from 1979 to 1987 here in Texas, and he was the chair of the Committee on Energy and a member of the Transportation Committee. His strength is transportation, and logistics. In 1989, he was appointed by President H.W. Bush as a member of the Interstate Commerce Commission, which has something in common with me because I've started out as a transportation lawyer in Washington practicing before the ICC. Judge Emmett has a wide breadth of experience in transportation and logistics policy. Those of us here who live in Houston depend on him to get us through our tropical storms and our hurricanes and to shelter in place and to evacuate when told. He is the strength of the city in guiding us in calmness. Significantly, Judge Emmett earned his undergraduate degree right here at Rice University with a Bachelor of Arts degree in economics, and he earned his master's from the University of Texas in Austin, Master's of Public Affairs degree. Thank you very much and welcome, Judge Emmett.
Well, thank you very much. I am your obligatory government official to welcome you here this morning. Now, I'm going to have two roles. One, as you've already heard, I am a Rice graduate, and I am going to play that to the hilt. Second, I'm the county judge. You hear a lot about the city. I love the city of Houston, but the county's bigger. We have 4 million people in Harris County. We have 34 municipalities in Harris County. And so I'm going to have a little bit to say about that, but I've only got 10 minutes, so you can relax a little bit. Let's talk about Rice University and the space policy. I don't need to tell you, President Kennedy pretty much announced space policy at the stadium right here on the Rice campus. And you've all seen that speech, hopefully, many, many times, because that's when he also said, why do we go to the moon? Well, why does Rice play Texas? Because it's difficult. And that's true. It is. And we're going to find that out again the first game of the football season this year. But Rice also has another connection, and that is the land where the Johnson Space Center has a Rice connection. But there's even another Rice connection that you don't know about. How many of you have seen the movie 2001: A Space Odyssey? Come on, yeah. Well, see, when I saw that movie, that was the future. When you see the movie, it's the past. 2001's already come and gone. But they had a contest, a national contest, where everybody could say what they thought the black obelisk meant. And a student from Rice won that contest. Now see, you didn't know that, so you've learned something this morning. But they won the contest because they did not write a paper. They turned in a stack of computer cards. Now, you don't even remember computer cards, but those of us who took BASIC and Fortran and all that stuff, you know, we had to stack up these cards, and if you dropped the cards, it was big trouble. You never could get your program to run right. So much of that has come out of space policy, and it's been generated by it. Things like Tang, Velcro. You know, you just go through the whole list, and you realize how important space policy has been. I had an example, speaking of transportation and freight transportation. An ex-astronaut came to speak to a gathering that I had put on, and he was promoting the idea of moving really high-value freight quickly with vertical takeoff and landing rockets. Very similar to the old Buck Rogers, if you have ever seen one of the old Buck Rogers. And we started thinking about it. If you could go up and land in a matter of 3-4 hours, how quickly you could get anywhere on Earth, you could come up with a whole new slogan. Because if you cross the international date line, think about it. You can ship with us and we'll get it there yesterday. Think about that. It could change the whole way we do business, but it would probably be far too expensive. But let me talk about Harris County for just a minute to put that in perspective. You all remember the first word from the moon, right? What was it? Houston. The eagle has landed. If they had just said Harris County, my life would be so much easier. Because then people would know Harris County instead of Houston. But there is no question in any of our minds that the space program and the space policy that was outlined has so enriched, energized not only the nation, not only the world, but specifically where we are. And what's exciting to me, and the reason I jumped at the chance to come welcome you, is you're the ones that are going to carry that forward somehow. What a great policy to be talking about at a great university, in a great city, and in a great county. So thank you for being here, and I welcome you, and I look forward to hearing some of the proceedings today. Thank you very much.
Thank you so much for coming.
Okay, what a great start. Thank you very much, Judge. Our next speaker will be introducing the keynote address, but in many ways we could, as Elizabeth said, ask Mr. Abbey to give the keynote address. George Abbey has a long and distinguished career, and you can read about it on the internet, including the director of Johnson Space Center, the guy that selected the shuttle crews, the astronauts who went into space, a test pilot, a graduate of the U.S. Naval Academy. But I think the best way to describe George is he is one of the legendary figures of the American space program. George was there at the beginning, and he has managed to help our nation in space throughout his entire career. He's now here at the Baker Institute, and his official title is the Baker Botts Senior Fellow in Space Policy at Baker Institute. I know George as a friend. I know George as someone that has been an advocate for what we're doing here today. And in fact, we really wouldn't have this day today without Mr. Abbey. So I ask that you give him a huddle welcome and hear what he has to say.
Well, thank you very much, Charlie. I would like to also welcome you here to the Baker Institute, and as Elizabeth said, it's very appropriate that we're having this event here today, because what we do at the Baker Institute is all about public debate. We deal with public policy, and there are two sides to every question, and we try to look at those two different sides. So, as Elizabeth says, this is the place to have a meeting like this. I've been involved in the space program for a considerable period of time, as Charlie said. I've enjoyed it very much and enjoyed my career, and I enjoy being here at the Baker Institute. But the individual that's going to speak to you this morning is an individual that has a great deal of experience not only in the space program, but he's also flown in space. He's flown on 2 shuttle flights. One that went up to do a very significant activity in space. You've all heard about the Hubble Space Telescope. Well, our speaker was involved in a mission up to the Hubble Space Telescope that made it really what a great facility it is today. He not only did that, but also commanded a second mission up to the International Space Station, which contributed greatly to make the International Space Station what it is today. And it is flying as we are meeting here this morning, and there are 6 crewmen on board that space station. And after our speaker went up and rendezvoused and docked with a space shuttle with a space station, he then went up and became a crew member on the International Space Station. Last October, he went up on a launch from Baikonur in Russia on a Soyuz spacecraft, and went and docked with the space station and spent over 5 months on the space station and served as commander of the station. He's had a great career in NASA, and he's also had a very distinguished career in the U.S. government, being a naval aviator before he came to NASA, a test pilot, and was selected as an astronaut in 1996. In addition to flying in space, He also, I think, fulfilled a very significant role in Russia at Star City, because it's important that we be well represented there. And our speaker served as the chief of that activity in Star City in Moscow for a year. So let me introduce you to Scott Kelly, a great astronaut and a good friend, and an individual that has done a lot for his country.
Well, thank you, Mr. Abbey, for those very kind words. It's really great to be here today and have the opportunity to talk to you. My job today is to discuss and give a presentation on working in space, and fortunately it's not to debate space policy with you, because I'm sure you guys are much better debaters than I am. However, after I give the presentation, I would like to answer your questions, because that's the most fun part of doing a presentation to me, is to get that personal interaction with you. So what I'd like to do is I'm going to show a video in a few minutes to talk about my last flight to the International Space Station. And I'm supposed to talk about working in space, so I'll do that a little bit. And the most amazing thing about being a part of this space program for me and in my career was the fact that over the last 10 years, the United States and our international partners, Russia, the European Space Agency, the Japanese Space Agency, the Canadians, have built the most incredible orbiting laboratory that we could have possibly imagined. In my opinion, the most significant engineering feat that the world has ever accomplished, putting together many, many different modules in space, in a vacuum, while flying around the Earth at 17,500 miles an hour in extremes of temperatures of plus or minus 270 degrees, in a very significant radiation environment, put together by astronauts and cosmonauts in spacesuits that are very, very difficult to work in, connecting modules using very complicated robotic procedures, and hooking these modules together in some cases that were never connected before on Earth. So the first time these two modules, or two structures or elements, are seeing each other is in low Earth orbit. And then using that facility to do science. The reason we have it there is to do all these science experiments that researchers around the world have developed. And we're doing great work. We'll continue to do great work. What I also think is significant is I think the whole concept of having this orbiting laboratory is really an experiment in itself. And if we're someday going to go to an asteroid, perhaps back to the moon, certainly to Mars, we're going to have to know how to live and work in space for long periods of time, to have humans working there, but also to have the hardware that sustains the people, the electrical systems, the environmental control systems, the operational concepts that allow people to travel long distances away from the Earth and sustain them over long periods of time. So, the space station is important for many reasons, the science we do on board, but the fact that the whole program in itself is one large science experiment that will help us one day, again, leave low Earth orbit. Perhaps, some of you guys might have the opportunity to do that and venture to other worlds. It's an exciting program. Even though we've recently retired the space shuttle, we still have a space program in America, where we continue to launch astronauts on the Russian Soyuz to stay for long durations on the International Space Station. And someday, hopefully soon, we'll be launching American astronauts again on rockets and in capsules that were built in America. And, Still a very, very exciting time for the space program. It is a transitional time, but still exciting nonetheless. So what I'd like to do is show the video about my last mission, and we can roll that at any time. And I'll talk a little bit about it, and then have the opportunity to answer your questions. This is our patch. We were a crew of 6. I launched with 2 other cosmonauts on a Russian Soyuz. That's in Kazakhstan. That's my 16-year-old daughter. A tradition of signing the door in the room of the quarantine area where you've spent the last 2 weeks awaiting launch. The blessing here that the Russian Orthodox priest gives you is good because you're getting ready to launch on the rocket, and it's good to have God's grace is on your side, but also that water wakes you up in the morning because it's very, very cold. Sitting in our spacesuits getting ready to launch, some of my guests here looking, I think they're mocking me because I'm looking pretty bored. And this is on the stairs of the rocket. The Russians have been flying a similar rocket for many, many years, since the early Soviet days in the 1960s. Much different than the space shuttle, but very, very effective in getting people to and from low Earth orbit. Has a similar safety record as the space shuttle does. Here are the 2 cosmonauts and the Soyuz as it approaches a docking on the International Space Station. After 48 hours, we open the hatch, and now we're inside the International Space Station. Got some pictures here of just, living and working in space. Obviously, floating is fun, but there are other fun things about being an astronaut and working in space, and I'll talk about some of those later. It's not just the, the part you see about playing with your food and looking out the window. To me, what the best part about it is being part of a larger team.
So Scott, it's my great honor and pleasure to relinquish command of the International Space Station to you, my friend and crewmate.
Thank you, Doug. I assume command. It's a real honor and a privilege to take command of this great ship, the International Space Station.
Like I was saying, the best part about it for me is just being part of this very large team, not just the folks you have on board that you work with, but also the control centers, the engineers. It really is a team effort to make one of these missions successful and meet all your mission objectives. And that is really the best part about it for me, being part of this large team and working on something you feel very passionate about, and being successful when you meet all of your goals. We installed a new module on board the space station while I was there. The Space Shuttle Discovery came up on its last mission, and there'll be here's some pictures of that new module.
You guys ready? Here we go.
This is the commander, Steve Lindsay, the commander of Discovery, as we enter the module. And this, it's considered a storage closet, but because space is really at a premium and you need all your food and water and a lot of different, all the scientific experiments, having storage on board is very, very critical. And we also can have some fun. Obviously, I'm not really walking that fast. My feet would never be able to move like that.
Hello, everybody.
Hello, Mr. President. Welcome aboard the International Space Station.
Well, I am glad to be... Is this Scott?
Yes, sir.
Little time delay.
How are you, my friend?
I am doing just fine, Mr. President. Thank you.
Well, look, I wanted to call and just say how personally proud I am of you and all that you're accomplishing. We are always inspired by the images of you guys at work. I also understand there's been a lot of traffic up there. We've got a vehicle from every partner that flies to the ISS, right? So we've got U.S., Russia, European Space Agency, and Japan. That's a pretty good metaphor for how we need to live and work together. productively in space and maybe back here on Earth. Scott, I talked to Mark a couple of days ago. It sounds like Gabby's making incredible progress, and we're just thrilled for them, and so they're always in our thoughts and prayers as well. I know that's something that has been of deep concern to you as well. So I just want to let you know that.
Yes, sir. Thank you. She's really a true inspiration to all of us. I appreciate your words.
Yeah, like the president said, while I was up there, my sister-in-law, Congresswoman Gabrielle Giffords, was shot on January 8th, and I had about 2 months left of my increment before I was able to come home, which was, difficult, but, like many professionals have to do, not only at NASA, but in the military and other fields, you really just need to focus on what your responsibilities are and what you can do to best do your job. The President also mentioned all the visiting vehicles we had while I was up there.
Scott, it was a pleasure to be up here. We appreciate your hospitality. We appreciate you putting up with us, knocking your stuff off the walls, and generally trashing your station. And we're going to miss you guys. And so thanks for everything.
We're going to miss you, but most of all, we're going to miss Discovery. We wish her fair winds and following seas. Thank you.
Yeah, like I said, this was the last flight of the Space Shuttle Discovery while we were on board. The shuttle being retired obviously is bittersweet. It was an incredibly successful program, very, very capable.
Discovery departing.
We will probably never in my lifetime build a vehicle that is so versatile in its capabilities, but it can't leave low Earth orbit. It's physically impossible to take a space shuttle to the moon or Mars. So because of the amount of resources, economic resources we have to decide to retire one program to start another. This is kind of a run through of the space station. Here's the cupola, which allows us to see outside very well for conducting robotics activities and Earth observation, viewing the Earth. It's a very large facility now, probably about the size of a 4-bedroom house. This is the European Space Agency cargo ship that came up there while I was on board. There was also several Progress vehicles. This is a view going from one end of the space station to another, to the very other end, through the Russian segment, through the Russian, it's called the FGB, into the PMA, Node 1, the US laboratory module, and then Node 2. And then on either side of that, we'll be coming home tomorrow in the Soyuz. And that's inside the Soyuz. We landed in a blizzard underneath a parachute in Kazakhstan. The flying home in the Soyuz is like going over Niagara Falls in a barrel while on fire. It's much different than the space shuttle landing, but very, very, very effective in getting us home and home safely. Very rewarding, probably the most rewarding experience I've had in my life, being a member of this team of Expedition 25 and 26. So what I'd like to do now, I'm not sure how much time I have left, but if you guys have any questions for me about anything, just feel free. And I think we got some microphones. Yes, ma'am.
You said that you work with people from other countries. Do you think that strengthens the ties back at home?
Absolutely. I think, one of the most significant parts of this program, I think, is the international nature of it. Not only does it allow us to learn about these other cultures and gives us insight for working on other issues that are important to us, not just space, it has benefits in other ways. For instance, when the space shuttle Columbia, when we had that accident, had we not had this partnership with the Russians and the ability to fly our crew members and supplies on a Russian vehicle, we basically would have had to abandon the International Space Station. We wouldn't have had a capability to continue to service it without having the shuttle available. So it's really, really fortunate that we do have this international partnership. Yes, ma'am.
Good morning. Taylor Mills from Sharpstown High School. I just wanted to know, what are the spatial limits of low Earth orbit? I keep hearing that, but what's the distance or limit?
Well, the shuttle, the space station operates around 200 to 220 nautical miles. The shuttle can go higher. The Hubble Space Telescope is at, when I went to it in 1999, was at an altitude of 380 nautical miles. That's close to the limit of where the space shuttle can go and then still have enough fuel to do its deorbit burn and make it home. Certainly you could probably go higher than that, but then you couldn't come back because you wouldn't have enough gas to slow you down to re-enter the Earth's atmosphere. And the reason the shuttle can't go further is it's just too heavy, and it doesn't have the fuel capacity to get it out of low Earth orbit. And also, if you were able to get it out of low Earth orbit, the thermal protection system isn't designed to come back from deep space. So it's got basically an operating range of between 150 miles to up to close to 400 nautical miles. Yes.
Could you just talk about some of the more interesting experiments you did on the shuttle?
Yeah, we had 150 different science experiments that were conducted on board while I was on the space station. Some of those involve the humans being subjects, and others do not. There's kind of two categories in my mind. There are the human experiments where we are the subjects, and where the goal of the experiment is to understand how the human body reacts to living in a microgravity environment, and how we can implement countermeasures to allow us to live there for a long time, so we could eventually venture outside of low Earth orbit. Those experiments involve maintaining our bone mass, muscle mass, and those types of things. And then there are the other experiments, and those deal with material science, fluid physics, for instance, and other things. There's an interesting couple of experiments I'll talk about. One in fluid physics, where the goal of the experiment was to understand how fluids behave with certain designs of structures to help funnel those fluids from one location to another. And the application of this is to be able to build more efficient spacecraft, not only for human space flight, but also satellites. And as you know, we use a lot of satellites in this country today, from your cell phones to, all different kinds of applications. So, a lot of them involve basic science. We have combustion experiments to better understand the combustion process and to make more fuel efficient and more environmentally friendly sources of combustion that would one day be used in vehicles and other areas where we use that combustion. But very, very wide range of very broad range of scientific experiments we conduct on board. Yes.
Okay, I'm Casey from Austin High, but I was wondering, what are the type of challenges that you face of coming from space back into Earth, like bodily, like physical challenges and possibly mental challenges?
Yeah, there are effects of microgravity on our body. For instance, we lose bone mass while on orbit. We have countermeasures to reduce the amount that we lose, but they're effective to a point. The same thing with muscle mass. We lose bone, we lose muscle. The countermeasures work very well. When I got back to Earth, my vestibular system was affected, but in general, I think after about 24 hours, I was no different than on a shuttle flight where I spent 13 days in space versus 159 days. My most significant effect was I was just really, really sore for a few weeks, like muscle soreness. For instance, you don't hold your head up for almost 6 months. So when you get back and now your neck and shoulders have to support your head, it leads to some pretty significant, soreness in your neck because you haven't used those muscles in a long time. So, I lost some bone mass, and that was pretty it. From psychologically, on me, there was really no impact other than, I miss the space station, and I'd like to go back someday. And I'm not sure how much time we have, but how about over here? Yes, sir.
Would you say there are any mental effects in space? That you can have mental effects in being in space so long?
On a 159-day mission, no, but I could see where if you were traveling, to Mars, for instance, that's definitely a consideration. We do work with psychologists and psychiatrists, even on a 6-month flight, to prevent that and to understand the stressors that might be involved. Certainly with me, I had a major, family tragedy that occurred. So, there are potential effects, but I think, as we go further away from space, and if you're, for someone on a 2 to 3 year mission to Mars, it would be a more significant concern than just on a 6-month flight.
We've got about 10 more minutes if you do, and so we'll try to get you all's questions. As you know, we're webcasting this really literally all over the planet. I want to read a couple of questions for Captain Kelly that have come in. The first one is from Sam Fisher, who is debater in Ohio. And his question concerns space tourism. And his question is, how would civilians fare in space without similar training and physical conditioning?
I think if we're talking about space tourism to where you don't go into low Earth orbit, where it's just a ballistic flight, in other words, you get going really high, not fast enough to get into orbit, and you're floating in microgravity for several minutes. I think it's something that, assuming someone's reasonably healthy, it's not going to have, there wouldn't be major issues. And I'm very excited about space tourism. It'd be, I'm privileged in that I can share this experience with my brother, but it'd be great to share it with other family and friends, and hopefully someday people will have that opportunity to fly in space cheaply. I think, however, if we're talking about flying for multiple days in space, that presents other challenges, because even folks that are trained to deal with some of the negative effects of living in microgravity, it still can be difficult. So I think, if we're talking about space hotels and things like that, we're going to have a more stringent screening process and countermeasures that, due to NASA's experience with long-duration spaceflight, we understand what those countermeasures need to be to make it a good experience for the people.
And one more question from the virtual world out there. Aisha Samuels, who's a debater in New York, asks, why did you decide to become an astronaut?
For me, being an astronaut was something I was interested in as a kid, but just the same way kids are interested in a lot of different things. And being an astronaut was just one of them for me. I was interested in maybe being a physician, being a race car driver, playing for the Mets. things like that. And it wasn't until I was a test pilot in the Navy that I realized that the next challenge in aviation for me would be to become an astronaut and fly the space shuttle. And, you know, it wasn't until I was working as a test pilot that I realized that perhaps this was a possibility, and I had the qualifications to be competitive. So it was in other words, it was a kind of a long process for me to you know, decide that this is something I really wanted to do and pursue.
We've got two more, so
okay.
If you guys will hold your questions for one of our subsequent guests, I appreciate it. But we can
Yeah, yes, sir. And then
I was wondering, how long does it take for someone to be trained enough to go into space for extensive periods of time?
I think it depends on their, you know, prior experience level. If you take someone with an operational background and a technical education, you could probably give them basic astronaut training for a year and a half or so, and then a year or so of flight-specific training. That's kind of the model we used for the space shuttle. The space station, however, is much more, I wouldn't say it's more complicated, but because you have multiple modules, different systems made in different countries, the amount of training is, and because you have to do it in other countries, it's more significant. For me, on my first flight, I trained on my first shuttle mission for less than a year because the nature of the mission, and it was the fact that the Hubble was having some issues and we had to get up there quickly. And on my third flight as a space station crew member, I trained for over 2.5 years of flight-specific training. So it varies depending on the mission. Yes, ma'am.
I'm Carisha from the High School for Law Enforcement, by the way. I wanted to ask, what are the necessary steps to take in becoming an astronaut? Because I see how much you really love your job, and it would be a good way for people who would love to become an astronaut to know.
I think a couple of things. One is you need a good education and you need to do well. You need to do well in your career field. There are requirements that your degree is in a technical field, engineering, science, math, of subjects of that nature. But what I think is more important is that people choose a career field that they like, that they're interested in, not just because they think it can let them become an astronaut, but because if you're working in a field that you like, you're going to tend to do better at it. You're going to excel more easily, and NASA likes people that have done well in the current job they're in, because I think it's a reflection on how they would perform as an astronaut. So, you know, good education, good grades. You know, choose a technical field certainly, but then something that you're interested in, because I think you're going to do better at it. Good question. Thank you.
Thank you.
How cool was that, huh? More coming, but we want to give Captain Kelly another round of applause for joining us today. Okay, well, first on deck was someone that flies and works in space, and we'll have a few more of those during the day. The subject now shifts to the stuff you guys, the nuts and bolts. What is space policy? How is it made? How does this country determine the direction that we're going into in space. That's also known as inherency for you high school debaters. You know, I'm probably going to just overstate this for every speaker. We have an amazingly qualified panel here to share that with you today. Our first speaker is Dr. Neil Lane. Neil currently is a senior fellow in science and technology policy here at Baker Institute and a Malcolm Gillis University professor in the Department of Physics and Astronomy. And in fact, it's a return trip for Dr. Lane, who served earlier as the provost at Rice University. So all you guys that are looking to get those college applications endorsed, you can see Neil after he speaks. I know he loves that. And was a professor of physics here. He took a trip to Washington mid-career and did a couple things, one of which was the director of the National Science Foundation, the premier scientific position in our government. NSF, which you will learn about, is really the place that makes a number of funding allocation decisions to fund research and science throughout our country. Neil was selected by President Clinton to be the director of the Office of Science and Technology Policy in the White House. That's also known, and it's also called the President's Science Advisor. So as President Clinton was confronted with any variety of policy questions that had a scientific component, including space policy, the person that he turned to was Dr. Lane. Neil is a fellow Oklahoman and received his BS, MS, and PhD from the University of Oklahoma. And I'm proud to call him friend, and as you'll see, is just a warm, wonderful person that has a lot of information to share with you guys. So let's welcome Dr. Neil Lane.
Thank you very much, Charlie. Good morning, everyone. We are delighted to have you with us today to talk about space policy and what we all hope will be a very bright future for the American space program. I was asked to say a few words about science policy. What is it, who makes it, how's it done, why is it hard, and so forth. I have to make clear I'm not a space expert. I had some opportunity when I was working with President Clinton to learn a good bit about space policy, particularly budgets, which I'll talk about in a minute. But since coming back to Rice, I've had the great good fortune to work with George Abbey, who is a space expert, and so he is my mentor now, and I'm learning a great deal more. So, space policy, what is it? Well, I think you know that. Space policy is pretty much, in the context we're talking about it today, space policy is pretty much everything the federal government does that has anything to do with space. So launching rockets, putting satellites in orbit, building and operating the space station, taking people up and back, performing experiments on the space station and in laboratories here on Earth, and also launching big space-based astronomical telescopes. Space policy includes most of what NASA does, but it also involves other federal agencies. On the defense side, the Department of Defense, Air Force in particular, is involved with space policy. NOAA, the agency that worries about our weather and our climate, is involved with space policy and must work with NASA to make sure that the satellites we need to do the observing actually get built and launched. So there's real need for agencies to work well together, and I would say that remains a policy challenge. So who makes this policy and how's it done? Well, the major players, I'll look at the civilian side. The major players in space policy are the federal officials at NASA. So at the top of that list would be NASA Administrator Bolden and President Obama and the people that work with him. And then, of course, the Congress. Now, the Congress has 100 senators and 435 representatives. So they kind of outnumber the President and Charlie Bolden Doesn't seem like kind of a fair playing field for all this debate and discussion that needs to go on, but that's our system. That's the way it works. Now, one thing has already been said, but let me repeat it up front, is that setting policy requires a lot of discussion. It requires a lot of debate. And those federal officials, members of Congress, who are good at debate, who know what they're talking about, can express themselves, are more effective than those who can't. It's always good to pick an example, so let me just pick one example of a policy issue, and that's the budget. Money's not everything, but it's a lot. And you can't do much in space. You can't launch many rockets and satellites and so forth unless you pay for them. So we fight over the budget every year. And as soon as Congress and the White House figure out how to raise the national debt limit, which will happen, they're going to begin the difficult task of agreeing on next year's budget. Every year we go through this. We do our budget 1 year at a time, excruciating process. There's not much time left to do this time around because the new fiscal year starts on October 1, not so many months down the road. So my humble opinion is we won't quite get it done, but we'll see. You can always be surprised. And people will start working on that in earnest over the next few weeks. The other thing about budgets is there are two sides to the budget. You have a revenue side, mainly tax money, your tax money, my tax money, and an expenditure side. And when the expenditures exceed the revenues, you have a deficit, which is what we've had for quite a long time. I'm happy to say that we did not have a deficit during the latter part of the Clinton administration, but that was nothing, no credit to me because I was trying to spend more money on science and on space, not actually get a balanced budget. So let's talk about the budget. What's in it, how it gets set, why it's so hard to put together. So first, what's the budget? So I said what's in the budget. The budget as a whole is about $3.6 billion. We don't know what it's going to be for next trillion with a T, dollars. We don't know what it's going to be for next year. It hasn't been determined yet, but of that order, that's what we spend. We take in significantly less, but let's just look at the spending part. It's my favorite part anyway. So think of the budget, spending budget as a pie. So all the money the federal government spends in a year is this pie, and it's over $3.5 trillion pie. 2/3 of that is non-discretionary. It's things like Medicare, Medicaid, Social Security. You got to pay the interest on the national debt, various other kinds of retirement programs. So 2/3 of the pie is all those other things called entitlements and interest. You could change those. You could cut my Medicare, but a lot of older people don't like that very much, and it's going to require overturning a number of laws, not just the annual budget process. So 2/3 of the budget is very hard to get at, and in the current discussions doesn't sound like it's going to go down any. 1/3 of the budget is left. Over half of that is for defense purposes. Well, defense may reduce its budget somewhat, but not a lot. So what's left is 14%. So out of this big pie, 14% is available for everything else the government does. Housing, health care, science, education, homeland security, space, everything that's in all of those different, agriculture, all those different agencies. And it looks like that's where the savings are going to have to come from if we're going to have a very tight budget. NASA is in that 14%. And NASA is a budget of about $19 billion. Well, if you think of NASA in terms of the whole budget pie, NASA is 1/2 of 1% of all the money the federal government spends. 1/2 of 1%. So if people come to you and say we shouldn't spend all this money on the space program, going to the space station, sending astronauts up, telescopes, all that sort of stuff, just have a nice conversation and remind them that it's 0.5% of all the money the federal government spends. So how does it work? How does the budget get set every year? Well, the budget process is complicated, but we'll simplify it a little bit. It's messy. It involves a lot of discussion and debate, as I said before. It's, as one former head of state said, it's like making sausage. Better not to watch how it's done. Every year, we have to work on the budget. And the President and Congress must agree on how much money the nation is going to spend on all these things. And remember, the fiscal year starts October 1. The process starts about a year in advance, so last fall. In the spring and summer, the NASA administrator has discussions inside his agency and with all of the heads of various centers around the country, and decides how much money he needs for NASA to do its job and do its job well. So suppose he decides it needs $25 billion. He has all the right arguments to defend $25 billion, and he puts together a budget package. And he shoots it up to the White House in the fall, about the time you're getting ready to go to school, about the time school will start. And the White House Office of Management and Budget collects all these requests from all these different agency heads, puts them all together, works through all the numbers, tells the president that if everybody gets what they ask for, that's going to be too much money. So the president decides, how much am I going to spend? And of that amount, how much is going to the National Science Foundation, how much for Department of Defense, how much for NASA, how much for other agencies. So then, around Thanksgiving, the Office of Management and Budget sends a message back to the head of the agency, my case NSF, Charlie Bolden in the case of NASA. And the message is not a welcome message. It's, we know you asked for $25 billion and we know you could spend that well, but your president's only going to request 19.2. Well, the NASA administrator is not real happy. So then he goes to the White House, and in the sort of months leading up to mid-December, there are more discussions and debates, and I was a part of those inside the White House when I worked for President Clinton there, and I was on the outside coming in complaining when I was running a federal agency. So there are all these debates and so forth. And finally, around Christmas time, the president is preparing to make all these final decisions. Once the decisions are made, all the talk has to stop. So then the NASA administrator cannot go out to the press and say, well, I asked the president for this much money, and he told me I couldn't have it. You won't hear that kind of talk, because we're all all of us who work in the executive branch work for the president. Once the boss makes his decision, then we live with that as best we can. So then, after the president's made his decision, his Office of Management and Budget put all the paperwork together, get ready to go to the Congress. Because remember, there are these 435 congressmen and women and 100 senators who all have to agree, or many of them have to agree with the president. So that happens early in the new year. In late January, the president gives his State of the Union address, and he just lays out some of his budget priorities, but he doesn't tell you the details. And then in February, by law, the first Monday in February, the president sends over his budget request to the Congress. One copy to the Senate, one copy to the House. Soon as the budgets get to the Senate and the House, they start independently, pretty much, working on the budgets. First thing they do is take it apart into 12 different bundles, 12 different hunks of government, with several agencies in this hunk. NASA's in the same hunk of agencies as NSF, Department of State, Department of Justice, Department of Commerce, and that gets sent to a particular subcommittee that works just on that piece. And then another hunk that has Department of Energy in it gets sent to another committee. And those committees then start to work. They're given some sort of rough guideline as to how much money they're going to have, and so they start divvying up the pot and so forth. Their job, 12 committees in the House, 12 committees in the Senate. Each of those committees is to write an appropriation bill with the amount of money down for not only the agencies, but different activities going on inside the agencies. They have to run that up through the committee process in both the House and Senate, get their bill voted on the floor, and passed on to the president, and he has to sign it by October 1st. If that does not happen, and the Congress does not pass any other kinds of laws, then that particular part of government comes to a halt. That happened to me when I was head of NSF. It's really not a very fun thing. That's called a government shutdown. We've heard something about that not so long ago. We'll hear more about that in the coming months. Stay tuned. So why is it hard? Well, you know why it's hard. Even within the Congress, it's hard, as we've seen in these current discussions. Even within a political party, there are different views, and it's not so easy to reach agreement. In recent years, Congress has often not been able to get the budget done in an appropriate way, and they had to use various stopgap measures. Also, since the two parties generally don't agree on fundamental things like how much to spend and how much to tax and what to spend things on, you can certainly expect that the Republicans and Democrats are going to have a hard time agreeing. Finally, if Congress passes all these bills, they're likely to not be the same kind of budget the president wanted in the first place. So he's not always going to agree, and he may veto them, and then the process has to renew again. So how's it going to come out? You may be curious how this is going to come out. I'm also very curious. I have no idea how this is going to come out. For NASA, my guess would be not good. Maybe another flat budget, as it's been for a couple of years. Could be less, but hopefully not. And the same thing will happen to a lot of other federal agencies. Some of them will get significantly less money than they had the previous year, because the mood in Washington right now is to cut, not add. So keep an eye on the news, follow the budget process, but not too closely. It's a mess. And you're going to hear one thing one day, and it's going to swing the other way the other day. And so it's worth keeping an eye on. It's a process that's fascinating. The world watches in wonder as we sort through our budget mess. But don't get too disturbed by what happens on one particular day, because something else is going to happen tomorrow. Let me close my comments with a personal note and a request. I was just a year out of high school when the Soviets launched the first satellite, Sputnik, in 1957. I was working my PhD in 1962 when John Glenn completed 3 orbits in his Friendship 7 Mercury spacecraft. And I had the great pleasure to get to know John Glenn and have lunch with him at Johnson Space Center when he was getting ready for his shuttle flight, which he was very excited about. And I was a young faculty member already at Rice when Neil Armstrong and Buzz Aldrin walked on the moon in July of 1969. So I've been around a long time, and I have had the chance to witness the sort of unbelievable, extraordinary accomplishments of the U.S. space program, and NASA largely responsible for those, not just in space exploration, which has been extraordinary, but also in science, including the Hubble telescope that you heard about and that Captain Kelly was so key in ensuring continued to work and deliver wonderful scientific results. You're approaching the launch date of your career at a time in the future of our space program as the nice word is in transition, but another not inappropriate word would be uncertain situation. So I'm hopeful that this uncertainty will get resolved over the next several years, and that this country will emerge as a leader in space, in the peaceful uses of space, as it has been throughout my career. But it will require efforts of many of you and young people all across the country to make that happen. So here's my request. I'm not going to pass a basket and ask you to put money in for NASA. I mean, that's later. It'll come out of your taxes. So thank you in advance for paying the federal income tax. When you have a few moments, maybe before school starts, sit down and make yourself a list. It can be a very private list of what you care about, including principles that you intend to live by, and things that you think are particularly important and that you're willing to work for. Maybe your profession, or maybe just on the side, but they're important enough to you, you're going to spend some time on them. And if you believe, as many of us do, that our country should have an exciting, forward-looking space program and be a future leader, not just look past on the great glories of space exploration and science in America's history, then I ask you to consider putting the space program somewhere on your list of things you care about and plan to work for. And as I look out at you, I'm optimistic that you can do some things that we've been having trouble doing in recent years. I think you have some advantages we did not have, and I'll list them. First, you have an enormous body of knowledge about science and engineering, the result of over 60 years of the government's investment in research since the end of World War II, through programs at NASA, NSF, and other federal agencies. Second, you have access to all that knowledge and information and to people across the planet through the internet and the web and the many tools of information technology, all the result of an innovative U.S. industry. Third, in part because of the internet and the web, you know a lot about the world, about its wonders and its problems. I won't embarrass myself by telling you how little I knew at your stage. Fourth, you'll have fresh ideas, and you, certainly here, have the ability to put words to your convictions. Moreover, I think you understand the value of teamwork, including a diversity of ideas and people from different backgrounds, born in different parts of the world. And space is an international activity, and we will succeed by working with our partners around the world. Finally, and my list could be longer, I think you know the future will not be like the past, that indeed the United States will be a world leader in the future, not by telling everyone else what to do, but by being a reliable partner and leading by good example. So good luck with your careers. Don't forget to make the list. Congratulations on the many achievements for coming this far. Thank you very much.
Thank you, Neil, and we'll invite him back up after Alan to answer some questions. Let's put that in the perspective of what you all are studying. You heard real world. Remember last night I said you got to include the real world in what you're doing. You heard two real world disadvantage discussions in that presentation. And if you go back to the materials that were prepared for you, you will see first the trade-off disadvantage, that when we elect to fund some space programs, others might have to be reduced. The example, I think, in your materials is the Webb telescope. We can't afford everything. Neil just described that real-world process to you. That manifestation will be in your trade-off disadvantage. The other disadvantage that you have that Neil described very aptly is it's labeled politics. And it's the argument that the president only has so much political capital, and that when a president extends himself or herself on specific issues, in this case budget issues, those things sometimes come back and bite you, and you have less ability to maneuver in other policy areas. The budget is intertwined. It is a scarce resource. There is only so much money that we can raise or borrow. And when someone advocates a particular policy, be aware that trade-offs are likely to occur and that political capital will be expended, and that capital can't be used in other policy areas. And those are two arguments that, if you're not already familiar with them, you will find them in your materials. And so again, my point is, what we're trying to do for you all today is to bring the real world into what you're learning and studying about, and I think Neil did a great job of that real world description. Now, on to the real world of NASA. And our next speaker is Alan Ladwig. And I left my formal introduction of Alan at the table, so you're going to get the Charlie Chafer. Alan and I have known each other for more than 30 years. And Alan started out in this world by organizing students that were interested in science and technology, and ran a Washington program that brought those students to Washington and put them into the real world of science and technology. More recently, when President Obama decided that how he was going to organize and staff NASA, he created what's called a transition team. Each agency has a transition team, and those people are appointed by the incoming president to advise the president on who to put in what offices, how to structure that agency. Alan was one of 4 members of President Obama's transition team at NASA, and they talked him into staying on for a second tour of duty at NASA, where he's currently in the Office of Communications and working directly at NASA headquarters. Prior to that, he was the Associate Administrator for Plans and Policy at NASA under President Clinton's administration. So NASA has been lucky enough to have Alan's talents twice now, and in the interim, he went off and did the stuff that I do. He went out into the commercial world and he worked for, besides me, he worked for a company called Zero Gravity Corporation. He worked for Space.com, which you guys need to be visiting kind of regularly, and he worked for Northrop Grumman. So Alan brings, and by the way, in college, he was a speech student. So Alan brings a wealth of experience, a real-world perspective on NASA as it is today and where it's going. And so let's welcome again, I'm privileged to say, my friend Alan Ladwig.
Well, good morning. I've got some slides I want to go through. I'm going to go through them fast because I'm really more interested in getting your questions. And that's because, as you heard Dr. Lane talk about the budget process, it's a struggle to go to work every day and remain optimistic and upbeat. And so rather than jump off the building here, I'd rather hear from you, because I always get a big energy charge when I get to go out and talk to students. So I'm counting on you to send me back to Washington with a revived attitude and a positive outlook on the future. Our vision at NASA is very simple. We want to reach for new heights and reveal the unknown so that what we do and learn will benefit all humankind. From a policy perspective, we do a lot of things to support that vision. I'm not going to get into all of what NASA does today because we don't have time. And it's so many things in aeronautics, in space science, earth science, human operations, space station. I'm mainly going to focus on human space flight today because we don't have time to do the whole thing, and it's really hard to even keep up on all the many things that NASA does. But for your debate topic, I thought it'd be useful to talk more about human space flight today. I think that'll be the core of what you're going to look into, but also because right now, with the end of the shuttle program, there's a lot of national whining going on that says, oh my God, America no longer has a human spaceflight program. Baloney. We do, and I'm about to show you what that program looks like. Now, one of the things you have to do from a policy perspective with an agency is you have to align yourself with what the president wants to do. Too often in the past, NASA got in itself that it was so important, it had so many things it wanted to do, that it wanted to do what it wanted to do, not necessarily aligned with presidential priorities. So this time around, we're trying very hard to align with the President Obama's goals of innovation, first of all, to win the future through innovation, education, rebuilding infrastructure, reforming government, and restoring faith in government. And the things we do now align very well with that, as I said earlier, through aeronautics, space science, earth science, human space flight, and human operations in low Earth orbit. Dr. Lane talked to you about the budget and what NASA looks like. Here's how it looks on a graph. We're actually 0.45% of the federal budget of $3.7 trillion. So that's a very little sliver of the overall federal pie. You can see this chart in other ways through boxes on the White House website. But just as a perspective, keep in mind that at the height of the Apollo program, which is seen as the ultimate thing that NASA's ever done, the greatest thing NASA's ever done, at the height of the program in about 1966-67, NASA's budget was 4.5% of the federal budget. So the decimal point was moved over. And so when people now say, well, why aren't we doing things like we did during Apollo? Well, for one thing, we've got a much less budget doing a much wider number of activities. Then to further let it be known that those who say, well, we have no human spaceflight, well, that's funny. We're spending 57% of our budget on human spaceflight. And that works out to about $8 billion of NASA's budget is devoted to human spaceflight activities compared to science, which is about $5 billion, space technologies, we're asking $1 billion, aeronautics, $469 million. That's down from $1 billion when I was there 12, 13 years ago with the Clinton administration. Education, only $138 million, and everything else about $3 billion. And then within the human spaceflight budget itself, there's everybody saying, well, you know, you canceled Constellation, and now you don't have a program of moving humans beyond low Earth orbit. Well, wrongo bongo, as George Abbey used to say, because 39% of that budget is for deep space vehicles, the Orion crew capsule and the shuttle launch system. 40% is spent for the space station, International Space Station, only 12% to help develop these new emerging commercial companies, and about 9% to phase out the shuttle. And that means safing the vehicles, closing things out, getting rid of the millions and millions of pieces of hardware and equipment that came with it, and then finally sending the orbiters out to museums where you'll be able to see them up close and personal. But we are at the end of an era. We're at the end of the shuttle program. After 30 years, the first flight was in 1981, we have had 135 flights. We ended last month, and we are now going to go forward. So while it is the end of an era, it also offers new opportunities. And it ended on July 8th when we launched the Space Shuttle Atlantis. It's been back now, and so there will be no more space shuttle flights going to low Earth orbit or to the space station. However, we will continue to have the space station. The previous administration wanted to cancel the space station in 2015, deorbit it into the ocean, and that didn't seem to make a lot of sense. We've spent $100 billion on this program over the past 20 years, so why end it now when we've just finally fully assembled it with the last shuttle flight? So the Obama administration is keeping the space station going till at least 2020 to use for scientific, technical, diplomatic, and educational purposes. We want to utilize ISS as for what it was originally intended to learn more about a robust research and development demonstration program. It'll be used to understand human and robotic interfaces, and it'll be used as a place to test new technologies. And it'll continue to be an existing opportunity to participate with international partners. We've been going on with crew members on the space station for the past 10 years. There's been 100 launches to the space station from 4 different agencies, 150 spacewalks to put it together, 195 crew members from 15 different countries have spent time there, and it has traveled 1.7 billion miles since 1998. Pretty good mileage. So one of the things that I'm fascinated about the space station is the international partnership. What other program do we have in the world today where you have seen such tremendous international partnership? We've never had any major breakdowns of communication, no major arguments. There's some differences occasionally, but it has been going very well. I happen to believe that the International Space Station deserves to be nominated for the Nobel Peace Prize. Not for the station itself, but for the partnership. And if any of you have any contacts with the King of Norway, please let him know that. We'll continue now to use it over the next 10 years as a national laboratory. We're also doing things with private companies that are doing pharmaceutical experiments on board. We have partnerships with the National Institutes of Health, the Department of Agriculture. Other agencies are starting to come on board to use this as the national laboratory that it was intended to be. In the meantime, we're going to spruce up the facilities down at the Kennedy Space Center and make it a 21st century launch complex. Remember, a lot of the facilities at Kennedy were built in the 60s to support Apollo. They're starting to age, new technologies have come online. The sea and salt air down there hasn't done any favors to a lot of the things that have metal in it. So we are now making a major investment to upgrade the facilities at the Kennedy Space Center so that it can be a launch site for multiple rockets, not only the agency's own rockets, but also from the private sector. Meantime, we will continue to develop the Orion vehicle. This was a carryover from the Constellation program that was canceled by this administration. The Orion continues. We just did some water landing testing a couple weeks ago, and you can keep up on what Lockheed Martin is doing with the Orion program. Meanwhile, we'll also develop a space launch system. This will be a heavy lift vehicle that will take us and enable human crews to go beyond low Earth orbit. There's a big debate going on right now about what that should look like, what its requirements should be. The Senate has a certain vehicle in mind that it thinks we should build. NASA wants some more time to understand how much it's really going to cost, what kind of design it ought to be, and so the administrator has announced that we will probably come out towards the end of the summer with a definition of what that vehicle will be. We'll also need to develop new rocket systems. We're basing our rocket technology on technologies that are over 30 years old. We've not made a significant investment or enough of an investment in advanced launch technologies. We really want to invest in cutting-edge research, new technologies. Our chief technologist, Bobby Brown, has this great chart. I meant to include it here and I forgot it. But down one column it lists all kinds of different technologies: closed loop life support, rendezvous and docking, what's the word I'm looking for that for Bigelow? Inflatables, there we go. Inflatable things, a whole list. And then across the top, it shows presidential commissions and studies that have been done since 1969. And if you go down and look at those technologies, almost all of those studies over the past 40 years have said we have to make an investment in these advanced technologies. That's what NASA's supposed to be, at the cutting edge. If we're going to use off-the-shelf technology, who needs NASA? So we need to make that investment, and that's why the president asked for $1 billion. So we want to do things like automated rendezvous and docking, fuel transfer, inflatable habitats, and aerobraking. We want to take a look at in situ utilization on planetary bodies, automatic landing systems, electric propulsion, and the human-robotic interface. These are all important things that need to be done. And we're not just going to do this internally. We want to work with the private sector and external experts as well. We don't claim that NASA has all the expertise. There's other people out there that have great ideas. So through a program called Centennial Challenges, we want to go out and partner with private organizations and give them different challenges on certain technologies. In the upper left corner there, you see a vehicle that Armadillo Aerospace here from Texas had and won a prize in the Northrop Grumman Lunar Lander Challenge. At the bottom left, you see Doug Comstock on the left and Charlie Bolden, our administrator, on the right, awarding a prize for another program. Upper right corner was a new glove program we did, and down in the bottom right is a new program we have, a Centennial Challenge on green aviation. And we're also going to enable the commercial sector to get more involved in space exploration. And this has been controversial from a policy point of view because a lot of people are uncomfortable with the notion of relying on somebody outside the agency to launch our crew members and cargo. This is a change of policy, a change of direction for the agency. It is not without its risk. These companies have to prove what they can do, but we believe they're capable. They end up with a lot of people that used to work for NASA, young people coming out of college are signing up in droves to work for them. They still have to prove themselves. And what I'm going to go through real quickly is just some of the things that are going on to once again reinforce the point: human spaceflight is not dead. Blue Origin, again, a company here in Texas owned by Jeff Bezos, the founder of Amazon.com, has been experimenting with the New Shepard vehicle. This is for cargo initially, but also is going to carry crew members for suborbital launch. Boeing has had a program called the CST, Crew, I'm drawing a blank. That's the trouble with NASA. We got too many acronyms. I'm drawing a blank on what CST stands for. But that's their orbital vehicle that they're working on. And they've already done testing on it. Orbital Sciences up in Dulles, Virginia, is working on the Cygnus spacecraft. That's on the left. That'll be for cargo docking at the space station. And a new launch vehicle, TARIS-2, which is an artist's conception on the right, scheduled for testing. I think the first launch is later this year. Smaller companies like Paragon Space Development Corporation is helping with a crew transport air revitalization system. So we're trying to get smaller companies involved in subcomponent levels that are needed for human spaceflight. Sierra Nevada up in Colorado is working on something called the Dream Chaser, based on NASA technology that we did probably 10, 15 years ago. SpaceX is probably the one you've heard the most about, located in Hawthorne, California. They've got their Falcon 9 launch vehicle that has already orbited their Dragon cargo vehicle. It has completed 2 orbits of Earth. It has returned safely, and they're getting ready for more tests later this year. And then finally, United Launch Alliance, which is a company that's a partnership between Boeing and Lockheed, and they have been launching expendable launch vehicles, the Atlas V and the Delta IV. They've just signed an agreement with Sierra Nevada to look into the feasibility of launching their Dream Chaser and eventually having that for human spaceflight. Meanwhile, we continue to do analog missions for human spaceflight and field tests. Here's 3 examples of NEMO in the upper left. That's the NASA Extreme Environment Mission Operations. And in October of this year, the crew of NEMO will leave the comforts of the surface life and immerse themselves and live undersea as an analog to spaceflight. The upper right is Pavilion Lake Research Project, which is up in Canada. The NASA Ames Research Center is doing work with that. And then the bottom right corner is the Desert Rats, the Research and Technology Studies. And it's been operating for many years now and conducts integrated mission simulations in the Arizona desert near Black Point lava flow. Meanwhile, we'll continue to have human destinations. We don't have a specific goal set yet with a time scale quite as specific as Kennedy gave us with going to the moon. The conditions today to make that happen just don't exist. Apollo was a unique point in time where there was a national security threat, technologies that were available, and the national will to go and make sure the Russians didn't beat us. Those conditions don't really exist today, and it's been much harder to maintain a long-term goal. We've had several presidents since Kennedy that have announced major space programs, and they just haven't caught on. This April of last year, President Obama announced that he thought the next human goal should be sending humans to an asteroid, as you see in the upper left corner. And he has mentioned that by 2025. We don't yet have a specific program laid out to how to accomplish that, but we are going to work on that. Meantime, it's possible that in the future, other administrations may decide to do something either going back to the moon or eventually, and the President Obama has said, to go on to Mars in the 2030 time frame. The other big thing that's going on, especially with my office, is we want to move from vicarious observations for you to be directly involved in space activities. So we have a public engagement program we're working on that it involves everything from twittering about what we do and putting information out to bringing you in to actually participate in missions, be it a student program like my first job at NASA when I was a civil servant in the 80s. We had a high school shuttle student involvement program where high school students were able to fly experiments on the shuttle. We now have similar things on the space station. Our robotic programs have many opportunities for the public to engage. And so we're going to be focusing on that more and more. Because what we find is when the public gets directly involved, they get more interested, and it's not just watching somebody else do something. And then hopefully in the longer run, that'll help inspire our budget. We also inspire future leaders. That's a big part of NASA's STEM, science, technology, engineering, and mathematics. And that's a big goal of this administration. So NASA has stepped up, and we try to do as much as we can to inspire students. Another policy question for you to take a look at is what will be the impact of all these suborbital companies that are coming along that are going to offer space tourism. I think the first ones will get underway within the next couple of years or so. How are they going to change the way we look at space? If, in fact, more and more people from a diverse range of society get to go in space, will that change the way we see space? So it's not just a handful of government employees that are going to get to go, either from this country or others, but a wider range of people to go. And it's the kind of if you build it, they will come. Let's see what they think once they start going up. And as Commander Kelly said this morning, not going to be easy, still a lot to prove, but you've got companies such as SpaceX, or Virgin Galactic on the left, going to start launching people to suborbital flight. Other companies like Xcor, Space Adventures, and then you've got Bigelow, Robert Bigelow, who made his fortune in the hotel industry, is now going to have a space hotel, and that's what he's working on. And right now, he has 2 inflatable structures that have been orbiting the Earth for the past several years, the first private company to be able to do that with their own funding. And finally, why are we doing all this? Why are we going into space? Well, it's really about opening the Earth-space system for the benefit of humanity. This is really about becoming a multi-planet species. Now, that's a hard argument to make these days in the budget environment we have. We can't get Congress to agree on a budget period and then say, well, by the way, we need a space program because we have to move off the planet. That's a philosophical and conceptual leap that may be a bridge too far at the moment, yet that really is why we do this. That's what the Augustine Commission said when they did the study for Obama last year that led to the cancellation of Constellation, and that's what takes me to work every day, that we are doing this to benefit humanity and that we are going to change the world. So we will see you in orbit someday. I hope all of you will find a career in space. I am living proof that a humanity major can succeed in the space program because I have been all over the place with some of the most fabulous, fascinating jobs you will ever see. And then for more information as you do your debate, here are some things. We'll leave these slides for you all to review as well. But these are some good sites, especially nasa.gov. On the history side of nasa.gov, we've got all kinds of publications that are online that make fantastic research books for your work, and I would recommend these other sites to take a look at every day. And if you have any questions, while I was never a professional debater at my university, Southern Illinois, I did have a debate course and really enjoyed it a lot. So I am here to help you guys succeed and have a wonderful debate season coming up. Thanks a lot.
I'll invite Neil to join us and we'll take some questions. You probably got about 400 case ideas out of Alan's speech, hopefully. You did hear discussions about near-Earth orbit objects, multi-planet species, flexible approach, all the things we talked about last night. And there really is, you know, I hope you get a sense that here's what I believe, personal bias. Of all the federal agencies we spend money on, for the amount of money that we spend, we get a great return from all the things that NASA's doing. As somebody that's been involved in private sector activities since they began, I'll tell you that we wouldn't have commercial space activities without NASA and without doing the kinds of things that Alan's been talking about. There's a rich amount of stuff for you guys to figure out what you want to advocate in what Alan presented. So now we have a few minutes before that all-important lunch break where I'd like to open it up for questions, and if you will come up to the microphones and tell us who you are and where you're from, and we'll get to some of your questions, and we got a few people out there on the internet that want to talk too. So please, let's start with right here, please. Oops. There we go, now we are.
My name is Juana Rodriguez. I go to Sharpstown High School. My question is for Alan Ludwig. You talked about earlier about inflatable habitats, right? So how would the inflatable habitats affect not only human life, but animal life? And where will they be located?
Well, the inflatable habitats actually started as a research activity at the Johnson Space Center. And it was, for a time, discussed, and George, correct me if I'm wrong, but I thought they were looking for a time of maybe including inflatables in the current space station design at one point.
Going to space station and proving it there and then taking it to the moon and Mars.
Okay. So it would be, it's a different way of having a structure put together. NASA decided not to continue that, so Bob Bigelow came to NASA and asked if he could acquire that technology. So we had some licensing agreement with him, and he has taken that on now to further develop it from the private sector. So he wants to use that as a module that will be the core of his space station or his space hotel. And then, as George said, we could also look at that down the line for possible habitation modules at the moon or Mars or wherever.
All right, thank you.
Yes, ma'am.
Yes, I'm Ariel Davila from Sharpstown High School, and my question is, you talked about green aviation, but I want to really know what that's about, and how much waste is this going to create in space, and how much is that going to cost?
How much? What
orbital
waste?
Debris.
Orbital debris? Yeah. That's a huge problem. And we study it constantly. The Air Force tracks all the pieces. We've had instances where we've had to make sure that we have a situational awareness of where those things are so they don't impact the space station. But there's a whole science and engineering discipline behind orbital debris that I'm not as familiar with as I should. We want to try in the future to make sure that we design things that have that don't have a lot of debris, that are more, utilize more things that go up, but I'm not an expert in that area. Your other question was on green aviation. NASA's got a huge role in aeronautics. It's one of the things that most directly impacts taxpayers because we all fly airplanes. And in the green aviation, the goal there is to have quieter, more fuel efficient, and more quieter, fuel efficient. There's a third one I always forget. Lower emissions. Thanks, Charlie. And that's what the goal of that program is. And so for the next generation aircraft, you'll see some of those technologies. It takes sometimes 10 to 15 years before technologies that NASA does get to be incorporated into new products and services. So what we're focusing now are these green aviation technologies. We want to get them online as fast as we can, especially because I think it's 70% of an airline's costs go into fuel. So if we could have a 10%, 15% savings for them, that would be a very significant cost savings for both them and for the flying public.
Okay, we're going to go to the internet for a question for Dr. Lane from Eric from New Mexico. Wants to know, how likely is it that we will find complex life forms in the universe?
Good question, Eric. I'm not a biologist, but I think it's a question of when. I think the current scientific consensus, there are always people with different opinions. That's why debate is interesting. But I think generally the opinion is that we are not likely to find intelligent life any time in the foreseeable future. Sort of all the calculations that one can make with reasonable assumptions are that that's not likely. But my other sense is that most scientists believe somewhere in the universe there is, I guess, what Eric would call complex life, and you can certainly count me among them. Some people question whether human life is complex or intelligent or whether all those words apply. I think it's fair to say that certainly present company, human life is complex and is intelligent. As you know, the SETI project, which was to look for intelligent life in the universe, federal government stopped investing in that quite a long time ago, and then the private funding has sort of run out. Nothing has shown up yet. So my feeling is, we're going to find complex life. I'm not convinced anybody has observed it yet, although there are other views on that matter. But I don't expect to find intelligent life.
Yes, sir.
My name is Cedric Adams, and I'm from Madison High School. And my question is for Mr. Neil, was it? Allen. Okay. You spoke of enabling the commercial sector and making an impact and changing the view of space. Also, you spoke on what the risk was, and I have a multitude of questions, so please excuse me. How would the inexperience of the new scientists just coming out of college and just jumping straight into this program affect, what's the word? Affect the
reliability?
The reliability of the program.
Well, for one thing, we don't just turn people loose on something and say, here, go do it. Although there's been some programs Charlie and I have been involved in. Secondly, there's a lot of professionals that are there already, and that's what you want, the professionals to train that next generation. The average age of NASA right now is about, I think it's 49, 50 years old. And an interesting data point, not only did we have a bigger budget in the 60s, our average age was in the, I think, late 20s, early 30s. Again, George will correct me if I'm wrong, but I think the guy that made the decision to override a computer warning was like 23 years old, if I'm not mistaken, maybe a little, but not much old. So we want to give opportunities to young people. As Dr. Lane stated very well, you all have a base of knowledge that we didn't have when we were your age. The technologies, knowledge management has increased so much. So I think it's going to be a good thing, just as we bring young people into NASA, young people go into these new companies and start to help bring that energy and enthusiasm and knowledge to help take us to the next level of space exploration.
The chair is going to have to limit you to one question because we have so many people asking, but you can grab these guys at lunch if you have a chance.
Okay.
Sir? Thank you. Please tell us who you are and ask your question.
I'm Joseph Collins from Challenge Early College High School. I have one major question and one brief question. My major question is, what elements can we get in bulk from the asteroid belt? And my brief question is, how much is Mr. Bigelow's hotel in space predicted to cost?
Address the elements of an asteroid?
No.
There's a range. I think it probably depends which one you're talking about. I've heard all kinds of minerals that will be there. Of course, the counter argument I've often heard is that, well, yeah, but if you bring that back, say if it's nickel, then does that do something to the prices of nickel here on Earth? It's a complicated process. I think we're many, many years away from exploiting asteroids to use on resources here on Earth. On the other hand, there's a lot of people that believe the real way to bring cost of space exploration is to utilize those resources in construction of things in space. So good question. Go to nasa.gov. I'm sure we got an answer for it.
And we talked about that last night in the non-terrestrial materials discussion. So
there is the issue, of course, of the big asteroid that comes and threatens to destroy the world. And that's so far science fiction, but it's not really a fictional set of scenarios. And so the more we learn about asteroids and the more we gain access to them, develop the technologies, the experience in space, asteroids tend not to be round and homogeneous. It's not so straightforward to work in and around them, so that someday, if the terrible thing starts coming our way, we might possibly have some way of responding, whereas today I believe the answer would be we do not.
And for your second question on Mr. Bigelow's hotel, I don't know what his current, or if he's even accepting deposits yet. The suborbital people are, and those flights will be in the $200,000 range. So I would imagine a stay at Mr. Bigelow's hotel will be somewhat more than that. So for your honeymoon, start saving now.
Hello, sirs. My name is Isaac Acosta from Northeastern Early College High School. I have two questions for both of you.
You have one question.
One question, sorry.
Sorry.
What is the real purpose for NASA? I mean, going into space, is it really that important for human prosperity?
Well, I think so. I mean, we've got a 45-year track record that shows the benefits that have come from our exploration of space in a wide range of activities, both philosophically, commercially, economically. It keeps us as a leader in high technology activities, advancing science. I mean, what would the world be like now if we didn't have the knowledge we have of all the planets? We have visited every planet but Pluto, and we've got something on the way there. Oh, yeah, and there's those people that don't think Pluto's really a planet anymore. We've continued to have advances in aeronautics, advances in earth science that have brought us better understanding of global climate change. And you can argue, is it human-induced or natural? You can't argue that global climate change is going on. So these are all the things that NASA does. It's a multi-purpose agency, and that's both I think a plus and a minus sometimes, because we have such a broad range of things we want to do. We have a limited budget to get that done. So that sometimes leads to inner struggles of, we need to put more money here, more money there. Some people have called for NASA to get out of earth science, to get out of aeronautics and only be about human space flight. That's a policy issue that'll be decided in the years ahead, and it's been discussed many times. But for right now, you've got an agency that was created in 1958 that I think holds up pretty well, and for 0.45% of the federal budget, I think it brings a fantastic return on investment to the taxpayer.
Let me add a comment. I certainly don't disagree with Alan. But the question does point to a debate, and Alan commented on it. There is a debate going on out there. And in the science community, you will also find scientists that say NASA really should move its money more towards science and away from human exploration, because they would argue that the scientific knowledge we have gained per dollar from human exploration does not compare with the scientific knowledge that per dollar that even NASA has provided from robotic missions. And so the community is divided on this, and you will find scientists who say very negative things about the human spaceflight program and who say those things about the space station, that given the cost of the space station and the risk to people in going and being there, that the science does not justify it. Well, science is not the reason the space station is there. I often draw the analogy with the Antarctic program, because when I was head of NSF, I went to the South Pole several times because the NSF runs the U.S. presence in the Antarctic. It's a very unfriendly environment. It's not as complicated as working in space. It's an unfriendly environment. It's expensive to work there. We are there not just for science. We're there because we've signed an international agreement in the 50s to cooperate with other nations of the world on ensuring the peaceful use of that continent. And the peaceful use is science. So the reason for being there is larger than science, but the best way to make peaceful use of a facility, whether it's the South Pole or it's the space station, is to work with your international partners, scientists in every part of the world, government people in every part of the world, together on a single peacekeeping operation. And science, you can't do better than science in that regard. So I'm a strong advocate for I was for the shuttle program. I am for the space station. I hope we continue to build on it. I hope we include China in the space station activities. Very controversial politically. I don't care about it being politically controversial. I think it's the right thing to do, and over time, I believe that will happen. So space station is doing excellent science. It will do more. and that will be the future of the station. So NASA has to walk this difficult tightrope in making the trade-offs. Very complicated, lots of policy issues need to be addressed, and we very much look forward to what you all have to say about those.
We are way into overtime, so I need to thank the Spartan Debate Institute at Michigan State University for their question that I'm not going to get to, and to Sue in Rhode Island for her question that I'm not going to get to, and ask your indulgence. We need to keep our schedule, and most of the speakers will be floating around, and I know they will be happy to answer your individual questions. So let's now thank these two gentlemen for a great presentation. Great to be with you. And we have your lovely parting gifts.